So, number 29 in your notes, and this is somewhere about 335 in the book, for those of y'all following along. So, a few things we need to talk about here first before we figure out how to calculate a half-life. The first one being, what is a half-life? Go, Rachel.
I have no idea, and that word gives me no context clues either.
Well, really? Layla.
A half-life is like the time it takes a piece of like an element to decompose, but it's like only half of the way.
Yes, it's the amount of time for half of that radioactive element to decay. So, or half of the amount of radioactive material you have to decay. So if you had 100 pounds of radioactive uranium, a half-life would be the amount of time it takes for half of that radioactive material to decay or break down. When I say, okay, so let's go back. When we say a radioactive element, what does that mean when it's radioactive? It's unstable, it's got unstable nuclei, it's going to lose neutrons, and that instability as it breaks down over time and loses those neutrons, that we call that decay. Sometimes I'll say breakdown or decay, but that's what that means, radioactive decay.
So half-life is just halfway to full decay?
So the time it's losing that radioactivity and becomes more stable. It's not decaying in the sense like it's completely disappearing. It could be like, let's say carbon-14 is a radioactive isotope of carbon. Normally carbon has 6 protons, 6 neutrons. Carbon-14 is radioactive. It has 6 protons and 8 neutrons. And so as it decays or breaks down, it loses neutrons and gets closer to that carbon-12 state. Does that make sense? Mm-hmm. So it's getting more toward how it should normally be. And so in terms of what you guys, in bio, this would be, we would use it for dating fossils and stuff and telling how old rocks are. But in our case here, we want to know how to calculate half-lives for radioactive material like nuclear waste. Or in the case of Chernobyl Heart, which y'all are supposed to be watching at home, and we are watching in class, how long does it take for that radioactive material to break down in the environment to a point where we could possibly consider it to be safe? So one of the radioactive elements that's mentioned a lot in Chernobyl Heart is Cesium-137. Cesium-137 has a half-life of 30 years, roughly. And so basically what's going to happen is if you had, a certain amount of cesium, let's say you start out with, we have this natural disaster, or not natural disaster, we have this disaster at Chernobyl, and at 0 years, we've got 100% of cesium that's leaked out of the reactors, okay? So, and we want to know how long does it take for 7/8 of that material that's leaked out to decay or break down. And another way of saying that would be, how long will it be before there's only 1/8 of that radioactive material left that was originally there? So that means roughly about 12.5% of what there was originally, okay? So after, and the easiest way I like to set these up is to make a little chart. And so the reason I'm throwing out like decay and how much is radioactive and doing it in a few different ways, you may be asked like, how long will it take for this percent of this material to decay or break down? And they would give you the radioactive element and they would give you the half-life, and you would have to figure out how long it takes for it to break down to a certain point. Or they could say, like, after so many years, how much of that radioactive material is still radioactive? So that just means that the amount that's not decayed or broken down, okay? So for our Cesium-137, after 30 years, how much of that radioactive material is broken down?
No, half of it, 50%.
Half of it. So we would be left with 50%, or you might also say 1/2 is left at that point. After another 30 years, how much of that radioactive material that we originally started with is left?
25%.
What'd you say, Luke? A lot of people think none, because if half of it breaks down after 30 years, you would think the other half breaks down after another 30 years. No. it's half of whatever you had originally. Okay, so at the end of 30 years, we've got 50%. So then we would have 25% that's left over after another 30 years, or 1/4. Okay, and then another 30 years. How much of that original amount are we left with? 1/8, or maybe I should do a backslash. 1/8, or what was that? 12.5% is left over. Okay, so how long did it take us to get to where 7/8 of that radioactive cesium is broken down? 90 years. So it took us 90 years to get to that point where we only got about 1/8 the radioactive material left. If we go another 30 years, we're up to 120. We've only got about 6% left. So we've got a fairly small number compared to what we started out with. Okay, which is significant in the case of Chernobyl because it's been 34 years since the Chernobyl accident happened. So we would expect the radioactive cesium to be about half of what it was originally. Yeah, so it's significantly less. So over time, more and more is going to break down, and you're going to have less and less of that radioactive material left over. Does that make sense? So you might see one question on the test, one on the AP exam. So I want to make sure that you understand this half-life concept. Yes, ma'am.
So like if like all of the radioactive material that's still in the plant that hasn't like leaked out yet, is that like also being broke down in the plant?
It is, but I don't know what the different components are in the plant. Like they keep mentioning cesium, which is I think one of the byproducts of uranium, since uranium's primarily used. But you also got to remember that uranium 235 has a half-life of 700 million years. So I'm not sure if like the cesium forms after that bombardment or whatever, how much of it's cesium, how much of it's uranium. That's probably a good extra credit question if you want to look that up. Because if that's the case, then it's going to be radioactive for a really long time. You've also got to think, yeah, you're continuously getting more radiation because the plant's still leaking radiation. But you've also got to consider that, when it rains, when there's wind, that radiation is getting blown and moved to other places too. So there is some more coming out continually, but a lot of it's also getting moved to different places. So the problem with Chernobyl is it's still leaking out. If it was just like, boom, it was out and they got rid of the rest of it, then you would just say, well, we know for sure how much is going to be left after a certain time period. But because some's still leaking out, it's really hard to tell, I think. Yeah.
If we have to do this on a test, are they going to tell us like how?
It'll tell you the half-life. It'll tell you, and it'll ask you, it could ask you a variety of questions. It could say like something like this, like how long will it take for 7/8 to decay? How long will it take before there's only 1/8 left? It could tell you the half-life, and it could say, like maybe it says the half-life is 50 years. And it could say, after 400 years, what percent of that radioactive material is left? And so you have to think, well, how many half-lives is that? That would be 4 half-lives. So you would expect like 1/16 to be left. So you really need to understand the concept of half-lives in order to figure out whatever's thrown at you.
How would you do it if it said like the 7/8 thing? Like,
Well, 7/8 is what we did. If 7/8 is decay, that means 1/8 is radioactive still.
how'd you figure that out?
Well, decay means the radioactive material is broken down. Remember we talked about because radioactive means it's unstable, and as it decays or breaks down, it's losing those neutrons, like it showed on page, I think, 333. And so these are kind of like the opposites of one another. You've got a total of 100%, but if 7/8 is decayed, the other 1/8 is still radioactive, meaning it still hasn't decayed yet or broken down. Okay? Okay, we'll look at some more, but I wanted to kind of introduce that today, make sure you had an idea of what half-lives were and a little bit about what that concept of breaking down and how to figure that out. And I'll see if I can find a couple of examples that we can practice on before the test, because I think there is one on the test. Okay, if you will flip over to Part G, Energy from Biomass. we are going to work through this section, and then we are going to finish Chernobyl Heart. For those of you at home who are watching this, all three of you, make sure that you are adding health concerns and issues to your notes on number 28, because I think those are important. Today is the saddest day of the bunch because they really get into the name of the movie, why it's called Chernobyl Heart, and some of the limit. I always say that as many problems as we have in America, you guys won the lottery because you were born here, and this video is a good example of what it just being born somewhere else, like in the Ukraine at that time period, not having medical facilities available, really puts a lot of these kids at a disadvantage. Just being born close to Chernobyl means you're put at a disadvantage. You're exposed to a ton of radiation, and you're more likely to have issues, health issues. So hopefully you guys will be appreciative of our health system, if nothing else, after today, because at the end, there's groups of American doctors and nurses that go over and help out with some of the surgeries that they're not really capable or ready for over there. And I think it is a good testament for people who are going to willing to go and help other people in other places that need them. So anyway, energy from biomass. Turn to page 344. Biomass. What is that, Aiden? What is mass?
So how much something weighs?
Yeah, the amount of stuff in it. And bio means
Nature.
life. So basically, it means living stuff that you can use for energy. Now, we use biomass for energy every day when we eat. Good. This is more talking about like to power your car or electricity or things of that nature. Okay, so that's what we're going to be focused on here. Number 30. Burning of biomass produces heat for energy at relatively low cost, but also produces lots of what? So let's identify some biomass sources. What are things used for biomass energy? What?
Calories.
No, I'm saying, no, let's not talk about, let's talk about, when I say energy, I'm referencing now like electricity or cooking or vehicles, moving vehicles, any of those. Natural gas is not considered a biofuel. These are things that can be grown and burned and used. Wood. Okay, wood's probably the number one biomass fuel. I have a wood heater at home that I use almost exclusively for heating my home. Good. Trees grow. I cut them. Well, I typically only use trees that are dead or fallen over, for my wood source. A lot of places people are actively cutting down forests, which is an issue we'll get into. What else? What biomass fuel do every one of you use every day?
What page are we on?
344.
You can't grow. You broke it.
Did every one of you use a car to get here?
Yes.
In the car, what does it say at the pump?
The corn
Diesel.
using the ethanol.
Up to
10%.
10% ethanol. Good. So when you put gas in your tank, it says up to 10% ethanol, and I'm thinking it's probably close to 10%. So unless you're using an old carbureted vehicle and you get the no ethanol gas, which I doubt any of you do. So you're probably using ethanol every day to transport yourself. Now, ethanol. What is ethanol? Ethanol is usually made from corn. Good. That's a big problem though, because we're using a food source for driving. What else? What is ethanol?
It's a gas. It's a compound of carbon.
Doesn't
It is a compound of carbon. Yes.
Doesn't F mean 3?
Yeah, I don't know about that. It's alcohol. Ethanol is alcohol. Like ethanol is the same basically as drinking alcohol. Okay? So when they use corn to make it, it's the same, basically the same process as like people in the mountains would use corn mash to make moonshine.
Like fermented corn.
Yes, that's why they're using corn, because they need the sugars in order to ferment it to make the alcohol. That's where the ethanol comes from. Okay? Now, it does burn very well. I'm sure y'all have seen probably, terrorists on movies, and they put a little like piece of cloth in the end of a bottle of liquor, and they light it on fire, and they throw it in or something, a building or a car. What do we call those?
It was that girl from Knives Out who burned up the medical place.
Yeah, Molotov cocktails.
Oh,
But they burn because that alcohol is the energy source. It burns. Good. Don't try that at home. So anyway, like some drag racers, we use like almost 100% ethanol because it burns so hot. You cannot put more than about 10% ethanol in your car because your motors are not set up for it, unless you have what type of vehicle? Unless your vehicle says it's E85, or some of the Toyotas I know say flex fuel, I think. If you go to the Mapco over here, you look when you're driving by, you'll see where it says E85. E85 means it's what type of fuel?
It's electric. 100% ethanol.
E85.
85% ethanol.
85% ethanol. So it means cars that are made to handle that 85% ethanol. For a while, I don't know if y'all remember, like 5-7 years ago, like gas got really high and a lot of people started using more ethanol, and there was a big push in E85 vehicles, and
Oh, I remember.
really not as many people were using because gas went down. Ethanol is typically cheaper, but I really think a lot of that's due to the massive subsidies that the corn people get from the government. So in actuality, I don't think it's that much cheaper. Another problem is, even if you get ethanol cheaper than you do gasoline, let's say you had an E85 vehicle, and you could put it in there. Normally, I'll give you a rough estimate. Normally, if your car got 25 miles a gallon with normal gasoline, and you put ethanol in there, E85, you would probably only get about 20 miles a gallon. It burns a lot hotter. You can't go as long as you can on gasoline. So it's really a wash kind of on the price there. Do not put E85 in your car unless it is specifically regulated for it, or it will destroy your motor. So anyway, I think in the long run, in order for ethanol to be a viable energy source for transportation, we have to figure out a way to use something besides corn to make it. There's been a lot of talk of, like, if you could take cellulose and break it apart, you can get the sugars there, and you could use almost any type of plant material. But that hasn't come to fruition yet. So we'll see long term if ethanol is a long-term source of energy that we can use in vehicles. We'll see. I'm still skeptical of using batteries in cars long term, just because of the environmental hazard or problems associated with lithium and cadmium and nickel and lead and all the stuff to make those batteries, and just having enough of that material to make batteries for everyone. So like I said, when you guys get old and I'm dead and you're got grandkids, it'll be interesting to see what you're driving around. Maybe little hoverboards that actually hover. Other things are just skateboards with wheels turned sideways. Am I right?
Yeah.
Hold on a second, need a drink. All right, what else? The overharvesting of, 30. Biomass produces heat for energy at a relatively low cost, especially if you're going out and cutting down your own trees. Or in India, what do they have lots of in India? There's like 700 million or 1 billion cows. It's like some ridiculously large number of cows in India. And they don't eat them most people don't eat them there, because of religious objections. But Lots of people use the cow poo. They flatten it out in like a little pancake form about that big, and they set it up and they let it dry out. And they will burn those dung disc. That's what I just made up. To cook their food. A lot of people do. I will probably show y'all a video of this when we get to air pollution because it's a big issue because it has a lot of, it also produces lots of, when you burn wood, you burn cow dung, you burn any kind of organic thing like that, and you don't have a very efficient stove or something to burn it in, it's going to give off lots of what? I would say particulate matter. There are fumes, but particulate matter, like the little dust and ash and stuff. Like, you know, when you're sitting around a campfire and the fire smoke keeps coming in your face and you can't breathe? Well, imagine like you're burning cow poop and like the dust and ash is coming off of that. So it causes a tremendous amount of like asthma and respiratory related issues. Yeah.
You know what I saw the other day when I was driving back from Spanish Fort?
I have no idea what you saw the other day when you were driving back from Spanish Fort.
I saw someone burning a tire. Like, and it was black smoke going into the air.
Yeah, burning tires is about the worst thing you can do for the environment.
Isn't that illegal too?
I would imagine so, but I'm sure it was probably some redneck out in the middle of nowhere. Yeah.
Why? What is the
Because it's a
point?
redneck in the middle of nowhere in
Yeah.
Alabama. They can do whatever they want.
Yeah, I don't know why people would burn tires other than to create a large black plume of smoke that is hazardous to your health. I have no idea. No, I'm not speaking to all rednecks out there, of course, as I grew up in Winston County. Let's see here. 31. The overharvesting of trees for fuel also causes what?
It emits
Deforestation.
CO2.
Deforestation. Good. What does it mean by overharvesting, Luke?
Like they're not using sustainable agriculture practices.
Yeah, they're cutting down more than they're letting grow back. They're not using sustainable practices where, you know, it's fine if you want to use wood, and I really don't think wood's, like I use wood for my heater. Now, the problem with wood is if you're going to cut down more trees than you're growing back, then you're eventually, what's going to happen?
There aren't going to be any trees left.
You're going to run out. Yeah, and so you see places in like Central Africa and Southeast Asia and even in parts of South America where people are burning forest. Some of it's for fuel wood, some of it's just for clearing for agriculture. But a lot of places, like let's say if you're in Central Africa and your village uses wood primarily for their fuel wood, and then as you burn and cut trees, then maybe you start like, well, I'm going to farm that area since it's already cleared off. Well, if you keep doing that and expanding out, you're going to lose more and more forest, and you're going to have less and less biodiversity, and you're not replenishing your needs around you for the fuel wood that you're using. So that's where the issue comes into play. On the burning and particulate matter, I'll tell you, I saw a news article from Britain the other day because a lot of people still have like wood stoves. Like back in the day, people used to burn a lot of coal in Britain because it was cheap. And then I think they banned that because there's so much particulate matter and smoke and soot and stuff that comes off of that. And so a lot of people started burning wood. Well, I burn wood, but I can imagine, like, let's say one of these neighborhoods across the street where you have a lot of people in a neighborhood. If everybody had a wood heater, it would be probably pretty thick with particulate matter. So if people didn't have, like, if they were just burning it in an open fire, it would release lots of particulate matter and probably not be very healthy for a lot of people with respiratory issues. Now, if you have a wood stove, what happens initially when you start a fire, usually there's some ash and stuff comes off of it. But once you get that wood stove like I have really hot, when you're putting wood in there, it's a pretty clean burn, meaning it burns most of it. And like if you're looking out the chimney, there's not ash or smoke or anything coming out the chimney because it's burning so well. But a lot of people don't have access to those type of heaters. Anyway, ethanol can be used as a substitute for what? Well, gasoline somewhat. My big problem with ethanol is that it's a food source and we've got to find a better way. You're not getting a lot of energy off ethanol. So let's talk about ethanol in terms of energy return. If I were to use 1 calorie to make some ethanol, I would only get 1.6 calories out of it. So basically, I'm not getting a lot of fuel in return for the fuel that I invested. Like farmers have to use a bunch of diesel in order to grow corn. And then you're only getting a small amount more off of that in return in ethanol. It's just not very efficient in terms of energy production. Aiden, are you okay?
Yes, sir.
You look about half asleep the last 2 days. Got to adjust that circadian rhythm, bro. All right, 33. Burning ethanol does not introduce additional carbon in the atmosphere. So using ethanol does not increase the net amount of carbon dioxide in the atmosphere. Why?
Because it's a biofuel. Because it burns at higher temperature. Does it burn more quickly?
Because the corn takes up CO2 from there, so it's like negligible.
Yes. So when you grow the corn, it takes in CO2 during photosynthesis. When you burn the ethanol, it releases the CO2 during the burning process. So there's no net gain there overall. Just like when I burn wood at my home in my heater, the wood grew on my property, it took in CO2, and then I burn it and it releases CO2. So there's no net change in the amount of CO2. Now, for almost everyone else, when you heat your home, you're using electricity, which is primarily using natural gas or coal, or you're burning natural gas in your home. So you have a net increase of CO2 there. Why? Where did that natural gas and coal come from? The ground. So it was stored in the ground. So you're increasing the CO2 in the atmosphere, which scientists believe leads to climate change and global warming that we hear talk about so much, because CO2 is one of our main greenhouse gases. All right. Any questions on the ethanol and energy from biomass? Yes, ma'am.
Where happens where part like after 30 months?
Yeah, so most of that over harvesting, a lot of that happens in Central Africa, Southeast Asia. Usually, and I guess maybe just the way to put it, probably the best thing to put would be in developing countries. So typically, poor countries are the ones that are using, very poor countries are the ones that are still using biomass as their primary fuel source. Because as countries develop, they start using more fossil fuels because they're easier to get and they're more energy dense, and you can make more stuff with them basically. People are able to mine and find more natural gas and coal and oil to use. So that's one of those, usually people in poor countries don't use much energy compared to richer countries. But if you're not careful, they can use lots of biomass fuel, which can affect biodiversity in a very negative way. Okay? All right, so we're going to finish Chernobyl Heart. You guys need to add in any health effects that are discussed in here. And hopefully you all won't cry.